bumps, bumps, bumps. So yeah, our quiz is here. I think we starting on 25. Oh, well. 40. 15 minutes is more than enough for this. I wanted to like kittens using my phone, but I cannot. Oh my god, the 5. Oh, Elaine. Actually, it doesn't matter. It doesn't matter in general. The problem matters. And uh, the reference frame is the x zero what? This one is quite quite made like base. Don't forget to falar da Don't try to basic stuff. Don't try to think that all the people try to some tricky stuff that basic basic sometimes so that's open everything. Comment that don't forget to write an answer. Seems I know your Don't worry about grades, as I told you. You will have much more quizzes than grades. Yeah. Okay. So let's go briefly through the exercise. So the first one, you just need to memorize the equation. So what is it? It's scalar. This vector. That's it. A property that it should be tangent to the path. That's it. First task. 5 seconds. Second, you can just write in pure rotation translation formation, as I explained it before. So first of all, so don't forget that we have clockwise, counterclockwise is positive, but actually it's up in, let's say, if you did it in clockwise in everywhere, you also will receive the appropriate result. So in this case, 100. So rotate about the axis. Actually, we always rotate about the axis in 2D. So 100 degrees. After this, so I decided, okay, it will be like this. So after this, Ey L1. After this, I can do Tx. You can choose whatever you like. I just show one of the possible. Two. After this, this is the hardest. You can rotate either, you can just do like this. T, Y, 3. After this, T, X, 5. So now we are like this. So we just need to rotate either like this or like this, and it will be mistaken. So that's it. Yes. Maybe I thought wrong, but I just we need to find the transformation. But to sum up, it's a little bit information. Well, can I show you how to do it? Actually, I can open it. Okay. And how? Well, the way I did it, it was like this. I mean, well, we have this like in midway, but I did not use this x prime, y prime. So I just we have this coordinate, and then we need to move to this. So I choose like this point and this point, and then I move -6 and on okay, you just calculated it and do. Okay, you can do it like this, but I show in general way if you are working with manipulator. I also accept this result, yes, because in one case you try to think and you will have easier result, or you just do as an algorithm, the one by one, and you will see this result. I have a question, but it's not. I understand the question below. So if we have like a reference frame, x and y, normal, and so we have a reference frame like this. This is the origin. For example, it is not really. And here we have the second one. Yes. So we have we need like transformation from here. So we have like a rotation around that, and we have a rotation around. Yes. In this case, you can just rotate around T. Yeah. So if you in this case, yes, right, and you need to yes. Yes. So the rotation matrix will be like formula goes like this. Why? Right? We don't have this. So right? Yes. Okay. So does the order of R it's about other angles. About other angles, we will cover it. Yeah, but we had the point. So it is the same or not? Actually, we have fixed angles and Euler angles. It depends on how do you rotate it. It will be problem on next two labs when we try to cover spherical, because it has some how to say, it has some properties. It's
15-20 minutes topic. Actually, Daniel have.
Yeah.
In this case, no.
You like, for example, you rotate around Z, around X, now around X, around Z.
Yes.
And I apply the first
but
rotation like at the end of the one. The first one to apply to the vector, the first one to, for example, if we have like now is rotation map. So we have we need to convert from here like a vector from here to a here, for example. So you have up, right? Yes. So the first one, for example. So this is the first one to apply. Yeah.
As I told you, it's fixed angles and Euler angles. We will cover it soon, and after this you will get how to work with it. And the last one, just open the slides from previous class. It's just the same numbers, just the same. So if you open it, it's the reason why I told you notebook open, not laptop open. As I told you, just 5-10 minutes and that's it. Most of the cases will be in the same format. I mean, quite basic, just to check that you did something before. And in this case, if you solve all 3 tasks, you will receive two score. I mean, 2 score, 2 mark. Yes. Other each of them cost 1/2. I mean half. It's like a bonus. If you say okay, I put in this again our formulas because we might help it. We probably will use it. This, and this. Okay, we may return to this, but also I think it's better to write some basic formulas on the whiteboard, because it's my common practice when I try to solve something and I know that this topic related to some particular one. I firstly try to write down all formulas which might be useful. Okay, today we are working with coordinates and with coordinates, velocities, and acceleration. So, what formulas might be useful? Okay, about velocity. This one. It's I don't remember. Do you know this equation? Yeah. Yes, when we want to find a new one, velocity, we have the pole that is the previous one and plus velocity from point P around point A. This we need to know that in planar case, it will be just like this. Will be a big rate. What else? What do we know? No. Of course, we don't. We need to know the same space for accelerations. Will be a tangent a normal. Of course, it also expands to normal and tangent. What else? How to find tangent? Actually, it's a length. No, I mean it's R. I wrote it R. Yes, of course. Omega. Yeah. Yes. Sorry, my.
You made twice as well.
Okay, it's a vector now. Okay. What else? What do we need to know? Any suggestions? Sleep.
Why do we need this?
Okay. So this blah blah blah. Okay. Also, I'd like to add a notation. Probably it's not one invented by Malaletov Alexander, but it's quite useful. So when we are talking about something, it's about this guy. I just saw in preliminary, but I show how to work with it later. The task, okay, study. We can highlight for ourselves. For instance, we need to find something. Okay, what I know about B? I know only a direction. To be one highlight probably underline one underline thing. But in this case, for instance, most of the cases know both direction and the model. I mean, absolute value. So in this case, you can see, okay, I know this, and this, and you can figure out somehow. So if you know only one, either direction or absolute value, you make one underscore. Yes. If you know both,
Yeah.
yes.
And how does
I will explain how. The sound, this noise, because I have a program which checks the temperature of my computer and it's shouting that I am too warm, too hot. 51%. Okay. Actually, let's turn off it. Home. The first task. Okay. The first task might be solved by you. Okay. Okay, so we know that it's the same, guys. Those that are middle point and
what do you know that they're
because of there.
okay. I thought you figured that
Okay. What's the difference between equation of motion and trajectory? Any ideas? Because you may see it a lot.
Trajectory is in the path.
Yes, it's in natural form, and the equation of motion is yes in this one. Okay, so we see the task, and we need to do this task. What do you think? I mean, what do you need to know? Okay, any suggestions? Because I don't want to solve it just as usual. Boo, 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 I'm looking at my whiteboard, and you just copy paste. Even more, you don't need to do it now because you have a video.
I see that B is moving in a linear motion.
Sure.
In a linear trajectory.
First of all, what is easier to find, M or B? Yes, B. So how?
Because M also has angular velocity.
So how do you find it? B. So what do we need to know?
First we start with
If we know coordinate A, we can double the coordinate A and get coordinate Y coordinate B.
So you're right. So much easier to find B firstly. And how we can do? We know that we have movement on x direction. We don't. So y will be 0. X will be what? It will be a length in this case. OA. Oh, okay. Yes. So we just need to make OA cosine C. Okay, but do we know this guy?
you know angular length.
Sure.
Angular no.
So P it's omega t. Because we know angular velocity, and it's like kind of path. Actually, we can write this equation to there, because it might be helpful for us. So we just put it there. Because, see, in our case, when we write it, we have what? X out of p. We want to have a parametric form. So we want to have x out of t. We need to put t somehow there. Yes, we put it there. And hooray, we found it. So, hooray, cosine, then t. Of course, we can somehow simplify it, but we don't need it. Of course, I will. It's clear?
So
yeah.
I not get like first line why OB equals 2 or 8 5.
Because we found this one, it's OA sine. And because it's the same,
okay.
Because of this x.
Okay.
So, how was that? We're done. Now let's go to M. Yarek, what do you think? What the guideline? What's our guideline now? What do we need to do?
Equation for P and
So we don't need B for M actually.
don't need.
Okay, so how do we find M in this case? What do we need to make first? Would you prefer try to receive coordinate? I mean, to receive the equation of motion or trajectory? What is easier for us in this case?
Yes, I think no one. Trajectory is so.
Trajectory is about path. We receive it now. There, it was trajectory. And when we have yes, it's coordinate. So, Insaf, what do we need to do now? Come on, guys. Penny.
So the first equation was equation of motion.
Trajectory because it was respect to t. Okay, I give you a hint. Of course, this point will have two x and y. So we need to find x respect to t and y respect. How can we do it? So it's just common geometric.
You make the triangle.
Yes, triangle.
The phi angle is
We already found NVD for t.
do we even know when AM or PM?
Projection.
Do you know PM or PM?
Yes, because it's the same. AM equal to MB. I do. No.
Okay. Oh, okay.
Semikalichka.
Easy.
Okay.
Okay.
Yes. So there is MB and A and blah blah. After this, of course, we again put theta to this and we receive t. What else? What can we do now? How do can what the how to say? How can we receive coordinate? form. What do we need to do? Become. It wasn't your quiz today. See my tier. So how? We received two equations of course. Then omega theta.
The one for x to the y.
Yeah. So what we need to do to receive. Okay.
Trigonometric formula.
In general, what we need to do?
Express t.
Yes, we need to eliminate t. Even though that it's respect to t. It's respect to t. We just have to do some magic and make it equal. So yes, in general, yes, we just need to eliminate t part. And in our case, it will be trigonometric formula. And actually, you know how it should look like. Try to imagine how it works.
It will be.
Yeah, your movement. Yes, try to memorize how it works.
Yeah, I don't know the word.
Okay, first, no. A. Let's play a game trying to find the word. Okay, it's an ellipse. You also could get it because we have sine and cosine. In this case, we can just use our common trigonometric equation, this one, equal to 1, and using this magic and eliminate it. So for solving some task, and if you want to eliminate t, it's better to have an idea what is it, what the trajectory in this case. It will be easier for you to find the better way to. Because when you have a just common line, you just need to put one to another and see. But if you have your cosine and sine, it's more difficult because you cannot just. Of course, you can arc sine and arc cosine, but it looks shitty. Yeah. So to sum up, this task was give you two approaches. First of all, you need to understand how to go from the coordinate to natural one and vice versa. And second one, to don't forget that actually now you're in geometry, and the triangle stuff is your best friend now. It was from the Musharsky tense paragraph.
Yeah.
This is my dummy translation. Are you with me? Kenny? You look so boring. I am trying to play la 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 la. Okay. Now we are see, we have 1 and now we have 3. Imagine, we just keep one task. Okay. So now try to pay attention because you will see this picture and how we are solving this even in midterm. If you won't get it now, you will get it in your home task. If you won't get it in your home task, you can go to ARC, except we can. And probably Henny with that on the halfway group. Okay. So we won't now I will show you how to solve this task in general. So we won't cover this task in okay, first of all, let's draw it. Because the next task, the third one, will be yours in class. Second one I will cover it by myself. The third one too. Okay. So it's called, if not mistaken, crank rod in English, but I haven't time to check it. My bad. In Russian, кривошипно-ползунный механизм.
Crank rod.
Not mistaken, you may Google.
No, it's the same in the rabbit.
I remember the crack, but it was about some drugs. Okay. I hope it's not crack. Okay. Okay. So we want to find everything. We want to find x, it's a vector. We want to find x dot, x2 dots. We want to find v. We want to find a. We want to find a normal. We want a tangent, and we also want to find k for it equal to curvature. Yes.
What is this omega?
Omega what? Ah, wait a second. It's spoiler. Spoiler alert. Okay. So, how we can start to solve this task? First of all, how many degrees of freedom this mechanism has? Okay, 3, 2, 1. Who's more? Okay, we won't cover formulas today because actually it will be the next semester. But you need to understand this intuitively. So, how can you understand how many degrees of freedom our system has? Just fix this guy. Can it move?
Yeah.
He can move. And using actually yes, it's stuck. It cannot move. Because you have
Because length is fixed.
yes.
And if you move it,
Yes.
that's
So
right.
it's the case. If you fix someone and it cannot move, 1 degree of freedom. If it can move, okay, 2 or more. And after this, you try just to fix and understand. It's just intuitive one. Of course, we have Chebyshev formula and blah blah blah, but forget about this stuff. We need to understand the intuition of the task, not this one. Okay. If you open this book, which we will use, I mean task from this because I have to translate it to Russian for now. You may see that the problem is that most of the tasks ask you to find velocities and acceleration, no coordinates. Why? What do you think?
Because dealing with project like too much math.
Sure. And you will get it now. Because in your home task, you should do it because you are using computer. Our books, which we are using, it's old books from 60s, 80s, and so on. In their case, for solving, actually, in Russian education, you have two courses, theoretical mechanics and mechanics and machines. But our mechanics and machines, which you will have on the next semester, is completely different. In original one, in TMM, theoretical mechanics and machines, so they did it. They had this mechanism. They have to draw 6 or 12 positions. So we move it, draw, move it, draw, move it, draw, and using vector, geometrical stuff, just using how to say rulers and so on. They found this stuff. They cannot make it analytically. Now you have computers, you can solve it analytically. It's the reason why we are not explaining you this stuff. But when I was in Bauman State University, I did it, yes, because our education is a bit outdated. So you don't need it. It's the reason why I told you we will code and we will use analytical solution then. Okay. We want, so in our case, what we need to find. For instance, we want to find all angles. In this case, we can, if you know all angles, we can, in general, find x respect to time. Because actually alpha is our, we have a motion, alpha, our angles, because it moves. In this case, we can do whatever we like, in any position. Okay, how can we solve it? Using geometry. In this case, you need to think, when we had a class, I see how to solve it, and because actually yesterday I chose another task, but now it says okay, let's change picture, and because it has a good picture. How can we solve it? What do you know? Of course, you know the position of your, X position. It's obvious because most of the time when we have a mechanism, we know all length because actually you weighed it. So we have this. Let's call it L3. You know this L1 and L2. We have alpha, the whole angle because we know it, but our alpha now can divide in two. It's because usually we have 90 degrees and we can calculate. So it's in a real case it's easier to have perpendicular stuff to calculate. Okay, what are our friends cosine and sine theorems? I mean, 3 plus 6 minus 2 kilograms and sinus. And alpha is not related to this. These two friends for you. On the next class, you will have one more friend. But for now, we don't need it. Okay, what we can do it? How we can solve it? So, for using cosine rule, what do we need to know? Two sides and angle.
But it depends what you want.
Yes, of course. Of course, there are different ways. But obviously, it's better to have two sides. And if you have three sides, you can do something else. So, in this case, we can find this one. How? We know this angle somehow. I mean, we know that it's messy, but I hope you are right. If we have this one, we can find, but we know this way. So we want alpha. So our, let's call it O B. It's about 3 divided by cosine. Okay, now we have theta there. We want to, we know L2, L1, and this guy somehow. And we know this angle, theta. Okay, let's write according to this. So it will be L2 square equals to L1 square plus B square minus L1 B sine theta. B, thanks. C. Okay, we did this guy. Of course, we can use some magic and receive this one. I won't solve it now because you will do it on your computer. But I'm showing that I just give some hints how you think. Okay. What else? What do we need to know? Probably we need to know this angle. We need to know how we can do it. If we know, in this case now, we know this angle. So we know there one angle and three lengths. Now we already know OB because we can put it there. Okay, using sine rule, we can take it. When we take it, so it will be now case OB sinus. I remember that it has a fancy look. Okay. using using either geometry or how to say our robotics. I mean this homogeneous transformation. We can receive any point there because we can just so yes, it looks messy, but sum up we can find all if we find all angles, we can keep this place, then what's the problem? Task, we want to find everything. Yes.
From a particular point, like
so in a common case, when in case studies, you used to work only with one position. So I told you, okay, 30 degrees, this angle should be, for instance, 5 degrees, and you find everything. I mean, all velocities and acceleration. In using computer, you can find the analytical solution for everything. So you will get the today you learn. I see he called it the velocity. Yeah. This point is this one.
Yes.
Did you get what the biggest withdrawal approach?
Biggest withdrawal?
Yes. For you when you're using computer. Withdraw. This is one of the approaches. Okay. For finding kinematics, you approach only one, just to use geometry and solve it. Now we are going to the velocities. How can we find it? Guys, there are several approaches.
I suggest that we start link by link, and for each link, we calculate the velocity and the angular velocity, everything. It can be like this is like methodology.
Okay, analytical solution. Okay, what else? Sure, it's the easiest one, the cheapest one. And of course, it's for you. It will be a bit messy to do it without computer, but originally, yes, you can just take derivative of our formulas and that's it. We'll receive everything. We can just dot and dot to dot. That's it. Nice. What else? This one. I mean, how in English again? Any instantaneous velocity center. Okay. The problem is that you can find it only for one precise angle. Because in some cases, for instance, for wheel, its point won't change. I mean, it will be on the one place. For this case, see, we move it moves, and it won't be there. It will be somewhere else. Yes.
Please explain what is it?
Okay, because you. So this approach provides you to. We have this equation for finding every related velocity. But this guy is not so nice for us in some cases. We can drop it. How? If you find this point where in this precise moment our velocity will be 0. How we can find it? We need to find the velocity of this guy. It will be direct to this place because we move, and in this case we know that our whole zone okay our slider move only in this direction, so our velocity cannot be in other direction. We need to make perpendicular between this and this without position. In this case, if you use this point, you can easily find it. We will do it now. And after this, you can find, for instance, this velocity. Because it will be just V, velocity P. It will be just V, P. And it will be omega 2 divided by about. We know this. Yes. Okay. What?
Oh, is it? Well,
What again?
yeah, it's gonna be equal to L3. Exactly. I was just calculating it by cosine.
Yeah, you can finalize our cosine or using this. Yes. The length will be the same, yes, but actually you can find it like this, yes. Like sine, yeah, and sine out, if you know. Yes, so L3.
No. This. Yeah, it's gonna be.
Yes, in this precise, yes, but if it moves, it's yes. You're right. See, if it moves for this precise, it's equal.
Yeah,
But
just at this point.
yes, in this point. But if we're talking about general, we need to take the cosine and sine. So sine doesn't matter. Of course, in this case, we don't know this guy, but we can find it because we know this point, and we can't find again. VA equal to omega 2, and this direction is sine. Sine, cosine. I forget. Yes, in this case, you can find it and put it there. In this case, we're using inertial or IC, IVC, and we can find our velocity. But this approach, as I told you, it's very useful for you when you're solving some task in a class. But when you're solving task in a real one, I mean, when you have a home task, it won't help because you need to solve it analytically. Okay, now we are going to analytical way, how to find the velocity. What we can do? Of course, we found this one. Will be 0 velocity. Okay. 0 plus, we know this omega and L1. Clear? Clear. Okay, after this we want to find V. VA plus V around A. Again, what we know? We know the direction of this velocity. I hope you agree because we know that it cannot move like this to spider. VA, we know what direction and yes. Actually, as you get, it's vector. Of course, I just didn't. And VA, what do we know? Because its rotation should be perpendicular to our, because we are using not cross product, we cosine 90. Yes, cosine 90. No direction. Okay, now we need to divide it in x and y axis. Okay, in y axis, we have VB, how we equal to 0, because there plus, and some cosine stuff. Again, actually, we received this again the same formula from ICB, IVC. Cosine, blah blah. What if because sine r and we have angle because we need to project on the about we have 0 there because we don't have the B. We have the A and again what with sine. Cosine doesn't. In this case, we found our velocity. Because this guy is almost the same. Any ideas how to find it? For D. Not for D, but for D. Of course, we know this. We know. Eric, please keep it every funny.
All of the away. I see error. For this we find velocity A, not this. We apply this to AB. Course.
You don't need torques.
I mean, like
Actually, you're right. Omega 2 we already found it. As you remember, sphere the vector we can put omega in any case because we found omega for the link. You just put omega there and that's it. It will be AD omega 2. That's it. The most difficult part is acceleration. Instantaneous acceleration, blah blah blah. Forget about it. We won't use it because it's useless. It's more complicated than IPC, and of course you cannot use it in analytical. So you just to expand your horizons, nothing else. Okay, about acceleration. The formulas. Okay, this guy. Okay, we need to write first of all. We need to write find a formula and a then a equals 0 because we don't have acceleration in the base plus epsilon L1 plus negative square root 1. We found each of them. Great. So return again. For if we want to find accelerations, of course, first of all we can find derivative. We can take derivative again, as he mentioned, then find the solution. Of course, it will be very big, but it will be a solution. Second way is we need to know all velocities because for finding accelerations we need to know velocity. Found it. Okay. Now we need to understand. Do we know the way the direction of acceleration? And we need to put it somehow. We want to find this b. It's normal because it should be, let's say, it should look on our pole. Okay, yeah. In this case. What? No.
Okay, collinear is
Collinear.
Okay, our tangent should be tangent. Yeah. Yes. We don't know the precise direction, but it doesn't matter. We just need to choose because when we will solve in yes, we just will receive minus. Yes. What else? What do we know? What do we know all direction there? Do we know the direction of A and B? Right? Even direction. Direction of who?
Direction acceleration. I mean, like in which direction accelerate? It's hard to know what to do.
Okay. So let's write A. Let's write in A. A plus A. Okay. Actually, we can substitute these two. Done. Okay, let's think for the no and the no. Can we found it? A can found it because we know the length and we know we don't know this one, we don't know that. So we know the direct. But we can find this one.
Yeah.
Okay. Then are you with us? Because now that you are. Okay, guys, 5 minutes break because it seems that you're done.
10 minutes.
No, we need to finish this task. And if you want, you may see video later. Да.
А на лекциях там настоящий.
Я говорю, у нас, я не вижу смысла в них перекатать. Это цирк. Attendance из цирк. Таня, где ты там потерялся?
Просто мне нужно.
Нет, это старание. Смотри.
Если старание.
В смысле, ты что-то объясняешь? А что? Ты сказал бы, мы тянем вот за эту веревочку. Эта штука, вот, нам нужно найти вот эту скорость. А ты что-то начал? Да, что мы делаем?
Мы находим все.
О, это офигенно!
Ей надо было упростить задачку. Я верил.
Ты ведь сказал, вот нам известно В, А, да?
Ну, смотри, что вас ждет дальше. Вас ждет раз домашка, два домашка, три домашка.
Если нормально там написано, что хотят,
Да.
а не так, типа, вот вам картинка, найдите все.
А там то же самое написано. Смотри.
А тут ничего не написано. Тут хотя бы что-то написано. Мы открываем Мещерскую.
Нет, это не из Мещерского, сорян. И она усложненная.
Другие.
Яблонский, да. Но, к
Да,
сожалению,
вот,
он вам не... Стоп, вы можете посмотреть, тогда, когда вам приходится ходить, там сложнее значит, стало.
Блин, я его открыл, там написано К2 и К3. Или К4.
Да, это просто название.
Пробуй.
Ну,
Я
понятно.
зашел в эту страницу, я искал, я не принял. Ну и ладно.
Ты решил сдать?
Нет, вопрос к тебе. На предыдущей лекции, не помню, как его зовут, говорил, что да, вот это вот Station Matrix, да?
Это я говорю, на лабе. Ну ладно, может быть, на...
Вот. А это Translation, да? Вот какого хрена вот эта штука не равна сначала Translation, а потом Translation. Это не равно.
Ты имеешь в виду, как бы вспомни оригинальную формулу. Там что у нас получается? Это как вот, там же Translation плюс R.
И ты не можешь сначала повернуть, потом перевести.
Да.
Нет, смотри.
Егор, ты вначале
Вот ты повернул,
ротайте.
переместил. Вот ты переместил, повернул.
Не, не про это. Или вот
Ты
это.
про это идет.
Это сначала поворот, потом перенос?
Да. Математика. Ладно. Молодец.
Не, я думал, это сначала Translation, потом поворот.
Нет, ты вначале поворачиваешь.
А
У тебя
чё,
по
типа-
формуле так.
А типа есть какая-нибудь такая штука, чтобы сначала транслейтить, потом поворачивать?
Ну ты берешь, ротейтишь на ноль, ротейтишь на ноль.
Чтобы в одном месте это все.
Ну да, а вот как я тебе показал, ты просто вначале делаешь ротейтишь на 0, а потом транслейтишь. А ты identity матрицу ставь на R. И всё.
Да? Ну, типа,
На rotation, на identity матрицу.
Ну типа да, я так и делал.
Yes, by the way, for like I checked last year's lectures, and you were, I don't know, you were directing them to watch the lectures
NTX.
from
NTX.
Yeah. Yeah. Is it I mean applicable to all cases also?
And to be honest, I don't remember what the videos, but probably the problem is that we have different, how say, slightly different topics. I mean, most of the people start from the statics. After this, go to the kinematics, and after this, go to dynamics. We decided that it's not very nice idea, and start from particle kinematics after this, rigid body kinematics. Only after this, we're going to static and dynamics.
Okay.
So
So it's gonna be like different.
Probably yes. Just try to find the same topic. If you find something interesting, either booked or let's say either booked or videos, it would be very nice to send it to our chat because let it help me and him. We have any very angry that we're using Russian. It's quite difficult. We try to find. We have about 7 books in our library, English books, but it doesn't look very convenient for us in the case. Actually, you may see that in Moodle I put 4 books. Yes.
The first one, I think, dynamics multiple.
It's good for some cases, but it doesn't cover.
Uses the same
I know this because we decided. I know it because he said us, okay, let's use this book because it has actually the previous lecturer also used it, but in his research, not in our class. Yes.
But the weird thing that this notation, like when I read like different books, totally like different, and even in MIT, like we're using.
Of course, it's the reason why I try to show you that there are plenty of notations, and that's it. You just, if you know more notations, it's better, isn't it?
I don't think like it is good in entry, like entry level. Yeah, because when you are learning, you get like messed up. I mean, first we are trying to understand the idea, then we get comfortable with the notation. So while you are learning,
if I were you, I just write down all possible notations and sheet.
Yeah.
Yes, and see. Okay, it looks like this notation. Okay, in this one.
Then you get a dictionary.
Okay. So about English books, I will try to find for you to help how to solve it. Actually, if you have formulas and pictures, you can even understand Russian because you don't need to read the text. You just need to see the picture. Because we are talking about accelerations, and now I understood that you just say goodbye to me. In this case, we will solve 4 and 5 tasks on the next class, and about weekly home tasks. That should be not solved only, but also coded, as I told you before.
Does
Have
it
a
mean
post.
to code it?
What?
What does it mean to code?
Okay, you got what I mean. Man, the solution should be coded.
No, like coded how?
With your fingers like this.
Like азбука Morse?
Okay, program and fast.
What do you want? Simulation?
Simulation. Simulation. You just need to use. I want that you need to draw it code.
Okay. I mean, for example, I need
Simulate. Okay, simulation. But okay, simulated. Okay, simulate. For me, simulated sounds not so. How to say? It's too epic for these tasks. It's like simulation. I don't know. And okay,
But I think
you will spend about 10.
I think you can provide like an example for what you want as a code, and with a.
I won't check the code.
So why
I will check. I will check only the plots, but you cannot make these plots without coding.
Yeah, you can make an example of what you need to talk.
You will get it now. Don't worry.
Okay.
So you can submit it 1 week later, but it's not recommended. I mean, so I will start to check your task from Monday. So you need to provide me until Monday. But if I don't know, you didn't get how to solve it and blah blah blah, you have 1 extra week.
With like negative points.
I don't think that it makes sense to make negative points for you because it's up to you. Each is a report, its solution, and info about tools which were used. I mean, you use MATLAB, you use Python, you just need to write. Okay, I'm using MATLAB, I'm using Markdown, I'm using LaTeX, and so. And solution can be a photo of paper sheet. I mean, you just solve it on your notebook, take pictures, and also plots from from MATLAB. What? The. I used to play MMORPGs a lot, so LFP, looking for party, looking for group, and so on. Okay. So first task. You find X, so it means that you need to. Actually, I will rewrite it. I mean, there are some mistakes in this. Let's say in this, I will send it till tomorrow, and they will fix it because I asked my supervisor to check, and then he found some typos. I mean, in general, you need to find in coordinate, velocities, acceleration, in analytical terms. So for every, let's say, for every point from -5 to 5. What?
What is perfect?
Yes, just Google it. I especially put this number word because you can find. Actually, it's 1 divided by. Yes. In some cases, it's more helpful than curvature because because of equation. You will get it when you have a first big home task. It's better to use this guy instead of this because in this case you can check some. You can write a code if my oscillating circle is equal to 0, for instance. You need to do some and vice versa. Yes.
It's not a circle.
Okay. So the next task looks almost the same as our class task. You have numbers. You should find x dot, x2 dots. It's in vector form. I mean x and y. Also you need to find absolute a. So all of this part, as I wrote there, I will edit. B, A, N, for B and C. If first task is easier for you.
Is the middle?
Yes. Actually, no, because you can see AC equals to 20.
I see.
I see. So we have constant angular velocity, so we don't have acceleration, but you need to understand that even if you don't have acceleration there, you will have accelerations in other points. And one cycle. I mean one full rotation. Close and necessary. So you need, in the end, you will put formulas, blah blah blah, and also that okay, from T, our A looks like this, and so on. It will be easier to, of course, you can, as I told you, draw of 24, I don't know, some positions and try to make it, but it's easier to pull. And I am asking about formal criterion in terms of that I want to understand that it's answer, these plots, don't forget about legend. If you don't have legend, I will be very sad. I mean that. So x seconds, I don't know, y, I don't know, hours. I mean about this one.
You want trajectory?
So
Maybe
you have
seconds,
two.
hours.
Is this trajectory? I don't know this. I mean in general, don't forget about it. Because it's really needed. If you do it in paper without this, they will say goodbye to the paper. Okay, and second one is more difficult. You may see you have two. Actually, you may get that it's from one task, but it's more difficult. Yes, and I will add some coefficient there. It's a task almost the same, but you have a harmonic oscillation there. So we in this case we need to say. Otherwise, we have some infinity stuff. We don't want it. So we say, okay, our t will be from 0 to 10 seconds. So we have 10 seconds, and we have this rule for this guy. Yes, it should accelerate like. I put 22.5 there, for that it will be it will intersect each other. for now it won't understand. It won't change the direction. I just checked the task, so there is. So this is free task, and we have 1 point. Both of them are half points, and this is a bit more difficult. Some hints. Actually, for solving this task, you need to write formulas, solve it. You can use any approaches you want. Of course, you won't use this instantaneous because you cannot code it. Other stuff are applicable. What else? You can ask me if you have any problems while you're doing it. But I hope you won't have problem. I also recommend you to open the Mishersky book and find some task and or whatever you like. I mean, the tasks look the same, and probably find the solution how other people solve it. In this case, even if you're using Russian books, you can just need to look at formulas and clause. In this case, you will get it. Okay, you may see it like this, that you have. So it's AN, you will understand that AN should be linear to our link and so on. If you have any problems with translation, you may ask either me or your classmate. Sorry, but for now we cannot find a very good.
Maybe is it like in the near future, is it possible maybe each unit we can get it from one book? Like you just tell us, okay, this book explains this unit.
Actually, see, we will have 2 books. One book is for from lecturer. We have tasks from 2 other books, Yablonsky and Mishersky. All of them are in Moodle. It's tasks. Solving tasks. And also, if we will provide you some paragraphs from the book. But the reason that sometimes this precise writer is not applicable for you. I mean that you cannot understand his explanation, but you can understand other explanation. It's the reason why we put several books, because maybe his explanation not good for you, but you will understand other. What else? Any questions? What about quiz? Was it difficult?
What about the first question? Yeah, you asked, this is your favorite formula.
Yeah, you asked to write in natural form, but we have this A dot notation. What do you mean?
I understand. Okay.
But I mean, like,
it was in the class.
Yes, it was in the class. But you told you did the math.
We just checked that you read the lectures. The slides after the class. If you didn't do it, you cannot solve it.
Well, we did. I did.
Yes, I see. You're the best learner now.